Lenz's law gives the direction of electromagnetic induction. It gives the direction of induced current produced due to electromagnetic induction. According to this law, this law gives the direction of induced current produced due to electromagnetic induction. This law gives the direction of induced current produced due to electromagnetic induction. Statement: the direction of induced current, the direction of induced current is such that it opposes the cause by virtue of it due. By virtue of it due. This law gives the direction of induced current produced due to electromagnetic induction. Statement: the direction of induced current produced due to electromagnetic induction the direction of induced current produced due to electromagnetic induction is such that it opposes the cause by virtue of it due. And this law act like Bhasmasur. Energy in this law, conservation of energy takes place. That is, the Lenz's law obey the conservation of energy. next term, self-induction. 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 The property of coil by virtue of which EMF produced due to flow of its own current. The property of coil by virtue of which EMF induced due to flow of its own current. Its own current is called self-induction. The property of coil by virtue of which EMF induced due to flow of its own current is called self-induction. If you let I equal to flow current, through the coil, phi magnetic flux produced then phi proportional I or phi equal to Li, where L is constant, where L is constant of proportionality, called coefficient of self-induction, or self-inductance, simply self-inductance. We know that the EMF E equal to minus d phi by dt, minus d by dt phi, putting value of phi Li minus L di by dt. This is the another relation for self-induction and induced EMF, equal to minus L di by dt. If I equal to 1, then from equation first phi equal to L. Now we can define the coefficient of self-induction in terms of magnetic flux. Self inductance. The amount of magnetic flux produced due to flow of unit current through the coil is called self inductance. The amount of magnetic flux produced due to flow of unit current through the coil is called self inductance. Unit of SI unit of L. SI unit of self inductance. L equal to phi by I. Weber per ampere, or L equal to E dt by di volt second per ampere, volt second per ampere, or volt second per ampere. Dimension of L. The most famous unit of L is Henry. Henry, H-E-N-E-R-Y, Henry. In honor of scientist Henry, the most practical unit of self-inductance is Henry. Dimension of L. Dimension of L. ML2 T minus volt का ML2 T minus 3 I minus 1 second T I A. Dimension of L is ML2 T minus 2 I minus 2. The next term is mutual induction. Mutual induction. It is EMF induced due to flow of current in other coil or neighboring coil. The EMF produced in a coil due to flow of current in its nearby coil or neighboring coil is called mutual induction. Mutual induction. The property of coil by virtue of which EMF produced in it due to flow of current in neighboring coil or nearby coil. In other words, the property of coil, the property of coil by virtue of which EMF produced in the secondary coil. EMF produced in the secondary coil due to flow of current in primary coil is called mutual induction. Primary coil. Secondary coil. Let IP equal to current flowing in primary coil. Phi S, so magnetic flux produced in secondary coil. Then phi S proportional IP or phi S equal to MIP. where M is constant of proportionality, where M is constant of proportionality called coefficient of mutual induction or mutual inductance. If Ip equal to 1 from equation first, S equal to M, we may define mutual inductance mutual inductance. The amount of magnetic flux produced in the secondary coil due to flow of unit current in primary coil is called mutual inductance. We have E equal to minus phi by dt minus phi s MIP minus M dIP by dt. SI unit and dimension of mutual induction is same as L, self-induction. The SI unit of SI unit and dimension